Hello 7th grade and welcome to my lesson 6-2 online video. Okay, so if you could open with me to textbook page 158 and 159, I want to pick up where we last left off. So the last time we met we were discussing graphs of functions, and we were discussing how to graph functions and the relationship between x and f of x, or x and y, and input versus output. So where we last left off, we were learning about function rules. Okay, so function rules is basically f of x stands for y here, and what we're looking at is the relationship between x and f of x, or x and y. So when I look here at number 10, for example, these equal coordinates. So if I plot -1, 5 on a coordinate plane, 0, 4, and 1, 3, this is going to form some sort of a pattern which would have a name, and the name of this pattern would be the name of my function. So what we're trying to come up with is a function rule. A function rule is just an equation, okay? No different than if I said y equals, say, 3x, or y equals x plus 5. So the first thing I want to do, some of these are kind of tricky, to be honest. They gave you some tough ones to start with. I'm actually going to start over here with number 12. This one's easier. So if we look, my question should be, so I'm trying to come up with f of x equals what? So how do I get from x to f of x? How do I get from -30 to -10? Okay, if you're going from a larger to a smaller number, usually you're dividing or subtracting. Okay, in this case we're dealing with negatives, so we'd be adding. So if I had -30 and I added 20, that would give me -10. However, 9 plus 20 does not equal 3. So that rule would not work for all of these. That would not form a pattern. So I'm going to go back up to my first number here. If I have -30 and I divide that by 3, would that give me -10? So if I take x, which is -30, and divide by 3, is that going to give me y or f of x? Okay, that's what I'm asking myself. So let's try it for the rest of them. 9 divided by 3, does that give me 3? Yes. 30 divided by 3, does that give me 10? Yes. Okay, so when I input -30, 9, and 30 for x, and then solve, that's going to give me my output. So my function rule for this problem here is f of x equals x divided by 3. Okay, when I look over here at number 11, this one's a little trickier. I'm not going to give you problems like this quite yet, just because it's a little more challenging. You always want to check to see if I can add, subtract, multiply, or divide first. When I check each of those, for example, if I say -2 minus 5 gives me -7, 0 minus 5 does not give me 1, 2 minus 5 does not give me 9, so that function rule would not work. And again, I'm trying to look for a pattern here to represent the relationship between x and f of x. Okay, so I'm trying to come up with my function rule given this table here. Okay, so we just said that subtraction doesn't work. What else could I do here? Okay, I could subtract and I can multiply. So when you go from smaller to larger, after you try subtraction, addition, multiplication, and division, you would then go to a two-step equation. So for example, how do I get from 2 to 9? Okay, plus 7 doesn't work, times 4.5 doesn't work. So now I'm going to try a two-step equation. So what if I decided to do 2 times 4 and then add 1? That would give me 9. Okay, so I'm going to try this function. 4 times x plus 1. So 4 times 2, when I input 2 for x, and then add 1, that gives me 9, or my output. So 4 times 2 is 8, plus 1 equals 9. Let's see if it works up here. When I take 0 and input for x, 4 times 0 is 0, and then I add 1. Does that give me 1? Yes. And then here, -2. When I input -2 for x, what do I get? So 4 times -2 plus 1, right? We're just doing substitution, you guys. So I take -2, put it in for x. Okay, this would give me -8 plus 1, which would give me -7. I have -7 here. So this rule fulfills the pattern for this table here, so this would be my function rule for this. Okay, most of these function rules are going to be a lot more direct, guys, I'll just be honest, than these two-step equations. All right, this is new. Very rarely are you working backwards like this, but it's still good to know. So I don't want you worrying too much about this, okay? This next problem here, the function rule is different. It's 4 minus x, okay? And how do I know that? Because how do I get from 1 to 3? I would try plus 2. I would try maybe multiplying by 3. Okay, that wouldn't work. 1 times 3, 0 times 3. The pattern would not work. If I do 4 minus x, 4 minus 1 gives me 3. 4 minus 0 gives me 4. 4 minus negative 1 gives me positive 5. So this would be the function rule for this set of ordered pairs. So I hope that makes sense. Okay, we're going to do a lot more work with this. I did give you some function tables before the weekend, last weekend, so hopefully you did that and were able to understand it. Okay, so I just want to show you, those are the answers to that. Okay, alright, and then next up, let's see, here we go. We have a word problem. So this is towards the end of 6.2. They want you to take this and put it into a function and then graph it. So it says, in one city, the cost of a taxi ride is $2 per mile, plus a base charge of $1.75. How can you show the fares charged for all possible distances? Let m equal the number of miles traveled. Let c of m equal the total cost of a taxi ride, okay? So here, c of m, this is going to basically be our y, and m is going to be x here. Okay, they're just using different variables. It's no big deal. Unless you use q. James, do not use q. You know how much I don't like the variable q. So that one's for James. We're going to stay away from q's, guys, okay? All right. So, in one city, again, the cost of a taxi ride is $2. So $2 per means times mile. And we said the number of miles is going to be m here, okay? Plus a base charge, so addition, of $1.75. That's my constant. So guys, if I get in the taxi, okay, and I sit inside that taxi, automatically before I go anywhere, it's going to cost me $1.75 no matter what. It doesn't matter how far I go. Okay, I can go once around the block, $1.75. I can go 2 feet and decide, nah, forget it. I don't want to take this taxi around the city. And instead, I could go 0 miles and still have to charge $1.75. So that's called our constant, okay? So this here would be my function then. So when I rewrite it, the cost of that taxi, so cost is always y, we talked about that, okay? So c of m just means the cost of miles here is going to equal $2 per mile plus $1.75. Or you could write it as $2 times m, like that, plus $1.75. Okay, so this would be my function here. Okay, again, c of m just represents y. All right, and then m here just represents number of miles. So now, I flip this thing over. Oops, I switched my variable. Let's see, give it a minute to focus. Here we go. So x here should be m, right? We just said that. So c of m and m. So this is called a function table. We talked about this. All right, so now what I want to do is put this function here into a function table and then graph it. So my x value is going to be the same as just m. So when I input m, okay, that's my independent variable because we can go 5 miles, 10 miles, who knows, all right? The cost here, c of m, so c of m is my y coordinate, okay? And my y coordinate cost always depends on the number of miles. So if I said to you, how much did it cost to travel around the city today? You could not answer that question unless you first told me what the number of miles that you traveled. Okay, so in the middle here, I'm going to write my function. So it's just 2 times m, and I put parentheses around m to tell me that I'm multiplying, plus $1.75. So now I'm just going to create a function table. So you're going to notice in your workbook pages that I'm going to assign to you, it's going to say create function tables, okay, and then graph, I believe. So we're just going to create our own function table here. So obviously we cannot go negative miles. Guys, think about it. Your x values here cannot be negative, right? We're only going to be in quadrant 1. Okay, we're not even going to look at these quadrants. Just quadrant 1 because I cannot have negative mileage. That makes no sense. So I could go what? 0 miles. I can go 1 mile, 2 mile, 3 miles, etc. So all I'm going to do here then is substitute, okay? So 2 times 0 plus $1.75, 2 times 1 plus $1.75, 2 times 2 plus $1.75, 3 times 2 plus $1.75. And then I'm just solving these. So again, I'm inputting m or x, and my output, my answer is going to be y or c of m. Okay, so when I solve this, I get $1.75, and then here I get $3.75, $5.75, and $7.75. All I did was multiply these first two numbers and then add $1.75. So 3 times 2 is 6, plus $1.75 is $7.75. All right, so now I'm just going to plot this, and it's going to be approximate. So if I start at 0, it costs me what? $1.75. So we're going to go about up to here. It's a little bit before 2. Okay, and then I go over 1, up $3.75, over 2, up $5.75, and I actually went off my grid for the next one. So I'm just going to plot these 3 points here. No big deal. Listen, you need at least 2 points to form a line. Okay, and we're going to stop it right here because you cannot go negative. So this would be right here. This would be my answer. Okay, as your mileage increases, so doesn't your cost. So we connect these because you can have like 1.5 miles, right, or 1.3 miles. They're going to have that. I don't think it's called a speedometer. What's it called? A mileage onomer. I just made that word up. Mileage keeper price thing. I don't even know what it's called. Bonus to those that come up with that. Like the taxi guys, know how you get in and they start charging you as soon as they start driving, and what they're doing is they're counting the number of miles exact to the penny so that they know how much to charge you. I don't know the name of that. Maybe it's a mileageometer. I don't know. Anyways, I just made that up. I like to make up words. Okay. So that's that. I hope that made sense. All right. Oh, and one more thing. We're talking about, this says what? 2 times m. So remember we said whenever you have, say, x or m, whatever, say this were 2x plus $1.75. Okay, we're talking about linear functions here, you guys. I told you that, right? When this is a single x, meaning it's just what? X to the first, automatically this is going to form a line, and you have to have 2 points to form a line always. All right, so linear functions, think linear x to the first, automatically it's going to form a line. If one of these points were off, I would know that I did not calculate my table correctly, because these should all line up in a straight line. So this is a linear function because x to the first makes it linear, okay? And you need at least 2 points always to form a line. So I would have to have at least 2 coordinates here to complete this line. So I could have just done 0 and 1 and called it a day, but just to double check my work, I always like to do an extra point just to make sure I didn't miscalculate. So, is that about it? Yeah, look at that. Oh, no. We got one more. Okay, so for, let's see. All right, so I think this is in your workbook page, okay? So we're going to be doing workbook page 177 and 178, which sounds like a lot, but it's really not that bad. And I just want to point out that on, let's see, here, on workbook page 178, numbers 13 to 20, okay, you're going to make a table of values for each function, and then you're going to graph them. All right, so for example, this is number 13 in your workbook. They give you y equals x plus 1, okay? They want you to set up a t-table, so this is all you have to do. All right, set up a function table like this, and I create x and y, and then what's my function here? X plus 1. Okay, so then I'm going to just create, these are all linear functions, guys. You only need 2 points. I'm going to do 3, so I'm going to do 0, 1, 2 here. And then I'm just substituting 0 for x, so 0 plus 1, 1 for x, 1 plus 1, 2 for x, 2 plus 1. Okay, and then I add those up, and I get 1, 2, and 3. And these are my new coordinates, so 0 and 1, right, that's my first coordinate. And then 1 and 2 is my second coordinate, or ordered pair, okay? And then 2 and 3 is my third coordinate, and I'm just going to plot these. So 0, 1, 1, 2, and 2, 3. Okay, I know the book says to graph them. If you don't have graph paper at home, guys, that's no big deal, all right? I just want you to understand how to